Now, the use cases for this particular integration are focused around visibility, network stitching, and application services. Visibility, you can think of it as a troubleshooting tool that helps you visualize how information or objects on the big IP are correlated to information and objects on the APIC. Think of it as giving you a great view of how your different constructs are correlated to each other between the F5 and the big IP. The second use case is around network stitching. This allows you to do day zero network configuration on the big IP, such as self IP, VLANs, default gateway, and not only do day zero configuration, but also then help you manage that configuration. This app or this integration is stateful, so the information that you configure on the big IP is present in the app database and you can manipulate it as required later on. The third use case is application services. This uses AS3 in the backend to deploy L4 to L7 configuration on the big IP. Now, if you look at the solution, it sits on an APIC framework called the Cisco AppCenter, and this is a native solution. What that means is this application sits inside the APIC controller. So as long as you have access to the APIC controller and the software for this integration, you can get working with this integration. So on the left-hand side, you see the app. Once you open the app, you will be able to connect and configure the big IPs that are part of your Cisco ACI fabric. Just a few more key points. The release for this application is a quarterly release. We are independent of ACI and big IP releases. As long as there is no dependency on the base code of ACI and big IP, we continue the development on the F5 ACI ServiceCenter and try to release it quarterly. In the phase 1 or the version 1 of this application, as I mentioned, we had the three use cases: visibility, network stitching, and application services. In phase 2, to network stitching, we also added vCMP support. In phase 1, we have support for virtual edition as well as appliance, and it also supports whether the big IP is in a standalone or an HA cluster. In phase 2, that was extended to vCMP support. And on the application services side, we introduced AS3 templates, which can now be used to deploy the application on big IP. In the future, we are focused on enhanced visibility to include traffic statistics and traffic analytics, and also focused on enhanced logging and fault reporting. We are right now part of a single APIC or a cluster APIC and an on-prem APIC deployment. The goal is to be able to extend this into cloud ACI, ACI multi-site, multi-pod, etc. Since it is a native solution, it is very easy for us to be incorporated into different APIC deployment options. Let's start by looking how we can get access to the integration. If we go to the website mentioned earlier and search for F5, we'll see the F5 ACI ServiceCenter on the Cisco DC AppCenter. Once you click on that Service Center, you will be able to view different details about what versions are supported, how you can get support for the particular integration, the user and deployment guide, and all other information that's related to the app. When you go on the APIC, this is the APIC controller, and when you go under apps, here is where you can upload the application once you have downloaded it from the previous link. Once you upload it, it will appear as a tile in your APIC controller. Now, before we get into the app, let's look at what is configured on the APIC. So we're going to use a tenant called Aspire Demo in this particular example. And under this tenant Aspire Demo, we have configured the F5 big IP as a L4 to L7 device. Now the L4 to L7 device, which is also called as a logical device cluster, defines what kind of big IP is defined. Is it virtual? Is it physical? And how is it connected to the fabric? So it's defining the physical connectivity of the big IP into the fabric. We have defined it using a service graph. A service graph is like a service chain where you have consumers and providers, and you have a big IP that is part of this service chain serving traffic between consumer and provider. Once you apply this service chain or service graph, you get a deployed graph, and if the graph is in applied state, your configuration on the APIC is in good condition. If we expand on the deployed graph that we are using for this particular example, we will see the VLANs that automatically get assigned to this particular graph inside of the APIC right now. So the two VLANs that we see here are VLAN 449 and 409. These are right now present locally on the APIC and not on the big IP. Let's log into the big IP as well to see what is configured as of right now. So we are under partition common. We do not have any virtual servers, pools, nodes, etc. assigned. But if we go in the network and look at self IPs, we do have one self IP that is defined to a particular VLAN. Now this self IP and VLAN are configured by the integration with a VLAN tag of 409. We will see how this looks like in the integration as we move forward. Let's look at another partition that's configured on the big IP called test1. Under this partition, we have a number of virtual servers, pools, and nodes. Now this configuration is not done through the integration, but consider it is as brownfield operation where you have some pre-existing configuration on the big IP. Now let's go to the app and see how we put all this together. Now let's open the integration, and at this point we are inside the app and we see different devices on the left hand pane that we can manage. All of these are big IP devices, and to add a new device you would need to provide the IP and credentials. As I mentioned, we do support VE physical as well as vCMP. Now let's log in into one of the big IPs, which is a virtual big IP. And as you can see on the top pane, we do have information like is it active, is it standalone, is it a virtual, etc. Now, there are three different use cases as mentioned. The visibility use case has three different views: VLAN, VIP, and node. In the VLAN view, you see there is a VLAN which was already on the big IP, and it shows how it's correlated to a logical device and tenant on the APIC. Now, let's go to the network stitching portion of the integration. When we go to the network stitching portion, we get a drop-down of different logical device clusters that are present on the APIC. So this app is a read-only into the APIC and a read and write into the big IP. Now, once you select the logical device cluster that is related to your big IP, it gives you some read-only information about the logical device cluster selected. And as you see at the bottom, it also pulls out the VLANs that are part of that particular logical device cluster. You select those VLANs, and since this is a stateful app, we see that one of the self IPs and VLANs has already been configured while the other one is pending. Once we click on Manage Selected, we can now configure that VLAN and self IP. We choose an interface, we provide it with a self IP, we give it a net mask, a traffic group, and a port lockdown. This information is all being pulled from the big IP. So if you have different interfaces, it will pull different interfaces. Once you deploy this on the big IP, you will be able to see that information in the app as well. Now let's look at the big IP to see what gets configured. If we go back to the common tenant and look at the self IP that got deployed, we'll see the self IP that we just defined and assigned to the APIC VLAN. Now, since it is a stateful app, say somebody goes out of band and changes a parameter on the self IP that was deployed by the app. The app is going to recognize this change and know that someone did something out of band and give a little out of sync information on the app. So once the user clicks on the out of sync, they will be given an option to see what is out of sync, which is highlighted in blue, and how do they want to fix it. Do they want to sync back to the big IP, or do they want to sync now what's on the big IP to the app? So they can treat whatever they want at this point as the source of truth to sync in either direction. I'm going to sync back what's on the app back to the big IP. And now your out of sync status has disappeared. This is the same thing that would be followed if you make an out of band change on the APIC. Through the integration, we can also configure a default gateway, which will be a similar UI experience as we saw for the self IP. Now going back to the visibility portion of the integration, let's look at a different view. We are still at the VLAN view, and here we see now we have the second VLAN that we deployed also show up correlating to the logical device and tenant. Now once we have deployed the network, now let's deploy an actual application with VIPs and pools, etc. So this is using AS3 in the backend. So let's define a partition, an application, and select a template. Now this is a simple HTTP template. We're going to provide it a couple of application servers, which are nodes. We're going to provide it a server port, a virtual address, and a virtual port. Now this is just one of the templates. There are other templates. All the other parameters that are not editable are treated as default. Now once you submit this, it is going to deploy the application on the big IP. Let's look at the big IP to see what got configured. When we log into the big IP, we see a new partition demo1 that is configured, and it has the VIP, the pool, and the node that we defined in that particular template. If we go back to the app, under application inventory, we will see what we have deployed using what template. And if we click on the view JSON, we'll see exactly what AS3 payload was passed on to the big IP to deploy this configuration. Now going back to the visibility and tying it all together, let's have a look at a different view. So instead of the VLAN view, we're going to have a look at the node view. And we are also going to select a different partition. Let's go with demo1. Now we deployed two nodes under the partition demo1. These two nodes will show up in the integration corresponding to it, the pool, the virtual, as well as the tenant, app profile, and EPG that it belongs to on the APIC. Now let's take a pause here. The workload that is on the big IP will show up here only if that workload is part of the APIC fabric. If these nodes or these workloads are not discovered by the APIC fabric, they will not be present in this particular view. Let's look at a different view of the visibility use case, which is VIP information, which gives you the same information in a different view. Let's also look at the other partition test1, which was created out of band, not by the integration. Here we had a bunch of VIPs, pools, and nodes that were configured on the big IP. Here you'll see a list that got configured and correlated, and you can use filtering on the app to be able to filter which VIP and which pool you're particularly interested in. So once you have the filter, if we scroll to the bottom, you'll see we are seeing only 18 records, versus if we clear out the filters, we'll see all the records that are present in this particular big IP. So let's clear the filters and scroll to the bottom. At this point, we see about 180 entries. Now, each of this activity that we have done through the user interface has an API REST call associated with it. So I'm going to turn my attention to Postman, which is a tool that's used to make API calls. And if we look at one of the API calls here, we're going to log in into the APIC first and get a token. Once we log into the APIC and get a token, we use this token for authentication in successive requests. So we're going to go into visibility, and as you can see from that post request, we are still talking to the APIC with a different REST API endpoint, and in the body, we are passing the big IP information. Now we paste the new token, and when we send this API request to the APIC, we get the response from the integration. And here it would give a response of what we just saw on the visibility table, all the nodes, their status, and which tenant app EPG they belong to. So as I mentioned, each and every click on the UI has an API endpoint associated with it. Let's have a look at the documentation again, and if you scroll to the bottom of this page, you will see where the user and the deployment guide link resides. Once you go to the user and deployment guide, on the left-hand pane you have the menu, and you click on the REST API, you will see all the REST API endpoints that are associated, what are the parameters that you can pass to it, and what would be the responses. As we saw from the demo, some of the key takeaways of this integration is, firstly, it is available now. If you go to the link that's at the bottom of the screen, you will be able to download and get started with using this application. It is a single point of automation with enhanced visibility because it is a native solution. All you need is access to the APIC controller. It is suitable for both greenfield and brownfield. As we saw in the demo, we had some configuration on the big IP that was not done through the application or that was present before the integration was used, and that information can still provide relevancy using the visibility portion of the app. If it is a greenfield deployment, absolutely, you can use this app for visibility, network stitching, as well as deploying application services. These use cases are not dependent on each other, so you do not have to use each and every use case to get benefit out of this integration. You can use it for just visibility or just for network stitching and or for deploying applications. As we saw in the demo, it is a stateful app, but I do want to emphasize that deleting the F5 ACI app will not impact any of your ACI or your big IP configurations. This app is sitting purely in the control plane. It does not affect the data that is flowing through your fabric. So you can delete or you can add this app as and when needed. The F5 ACI, as we saw, can also be automated. So if a customer is not using the APIC controller as their choice of orchestrator, but there is a different tool that is sitting on top of the APIC controller that is automating and orchestrating APIC, that same tool can now talk to APIC and talk to big IP through this particular integration, since the integration itself has API support to it. When it comes to support for the app, it is free of charge. It is supported by F5. Following a couple of the APIC releases, minimum APIC releases that we need on each of the version trains, and all of the future APIC releases on that train are supported. The minimum big IP release is 12.1 onwards. Thank you for your time and attention.